Hello, Mr. Price here, and this is the third question of the June 2006 M2 paper. And this one is a centre of mass and a little bit of what's it called? Moments. So let's have a look at it. So this one looks quite intimidating. We have a hemisphere, and it's not in its correct orientation, or what the orientation we prefer it to be in. It has a weight of 12 newtons, has a radius of 6, and we've got our two strings here. And what we want to do is find the horizontal distance from the centre of mass of the hemisphere to the vertical through O. Now, the question's been nice to us here. It's given us, it's asking us to find a value that's going to be very important for part 2. Okay, so let's have a look at this first one, and this is where a diagram is really going to help you out a lot. So we'll do its diagram first. So we have our hemisphere, like so, and then these are vertical, and we have this angle here of 60 degrees. Okay, and then this one, the major one, is 120. Now, we're going to want its centre of mass because it wants us to find the horizontal distance of the centre of mass through the vertical. So, there's our vertical line. Let's say the centre of mass was here. It wants this value here, this length. Okay? Where this is a right angle, and then you have this here. Okay, now we know that this string is at the center of the circle. Okay, so if we drew this hemisphere in its correct orientation, we know that by symmetry x bar is going to be the radius, and then y bar, using the equation in the formula booklet, is 3/8 of r. Okay, so y bar is 3/8 of r. Now, as we can see, there is this forms a right angle from the centre of the circle to the centre of mass. So we know that this is a right angle. Okay, so we already know this is 60, so this whole angle is going to be 120, but we only want this bit, so the 120 minus the 90, this angle here of importance is 30 degrees. Okay, so now we know that this distance from the centre of mass to the centre of the circle is 3/8 of r. So this is going to be 3/8 of the radius, which was 6 centimetres. So, oh, that's very blurry, isn't it? Sorry. Let's zoom in a little bit. Okay, so this is 3/8 of the radius, and we want this value. So now it's just a matter of trigonometry. So I'm going to draw this circle a little bit, this triangle a little bit nicer. So we have this distance, which is 3/8 of 6, which is 2.25, and we want this distance when this is an angle of 30 degrees. So using trigonometry, we have 2.25 sine 30 will equal this value, which is 9/8 or 1.13 centimetres. Okay, and that's part I done. So that was part I. Now for part 2, we need to find the tension in the strings. Now, it's been nice to us here and told us the horizontal distance to the centre of the circle. So I'm 2. Let's redraw our hemisphere again. So we have this tension, and then the weight of 12 newtons. Okay, and we know this distance here. Okay, so let's take moments at the centre point here, O. Okay, and that's 60. So that's 60, so this is 120. Okay, so moments about O. Okay, and here, I know sometimes I do them clockwise or anti-clockwise. I'm just going to do the clockwise moments on the left-hand side and the anti-clockwise moments on the other, because we know it's an equilibrium. So, if we've got a pivot point here and we have a tension going upwards, that's going to cause a clockwise moment. So, and we want the perpendicular distance from its from the pivot point. Okay, so let's have a look and see what's going on. So here's our pivot point. Here is the radius of our circle. And what's going on is we have a force going up like so. And we're going to resolve everything parallel and perpendicular to the radius of the circle. Okay, so I know that this is 30 degrees. And then I also have my centre of mass here going downwards. Okay, and I already know the perpendicular distance from part I, which was 1.13 centimetres. So T cosine 30 multiplied by the distance, which was half of the diameter, the radius was 6. So T cosine 30 lots of 6 is equal to 12 lots of 1.13. So this gives T1 equal to 2.61 newtons. Okay, I hope that's fairly clear. Now T2 is much easier, don't bother doing moments, you can just use Newton's laws. The sum of moments up must equal sum of sum of forces up should equal sum of forces down, or in any given direction. So I have T1 plus T2 must equal 12 12. Because if you look on the diagram, you have a force horizontally up, a force horizontally down, and a force vertically up, a force vertically up, and a force vertically down. So T1 plus T2 must equal 12. So T1 is 2.61 plus T2. So the second tension must therefore be 9.39 newtons. And that is all question 3 done.